Assalamu alaikum students. Today we will study the method or Newton's method, Newton Raphson method in Matlab, and how to apply the Newton Raphson method in Matlab language. We will do the code by using the algorithm of Newton's method. So take a review on the Newton Raphson method. First of all, for the function is given in the question, and the tolerance is also given in the question. And what you have to do, you have to find out the root by your own self by the opposite sign conditions. And after that, if the root lies in this interval, then you have to find out the initial approximation by that function and function derivatives at that point condition. So if the signs are same, then you say that that point, given point, is the particular point is the initial approximation to start with for the Newton's formula. And the iterative Newton's formula for that is xi plus 1 equals xn plus 1 equals to x of n minus f of x of xn divided by f dash xn. So basically you require function and its derivative. Suppose now we start with a very basic thing, and that is that we if the initial approximation is given, so what you have to do, you just have to apply the Newton's method. So after that, then we will start how to select the root and how to select the initial approximation. So that is the modified version of Newton's method. So first statement you require for that is function declaration, and that is func, because Matlab is a case sensitive, so you don't you have to be very well aware of this. So function and then square brackets, that is for output, and equals to whatever you want to name it as Newton. So I will write simple Newton, and then within that parenthesis I will write all the inputs I want to give it. So I want to give it, because the root here is the modified value of x, so I will say it's x basically. And then Newton, in the input you have to you have given f function, and in this you must calculate by your own self. The derivative is given in the input, and you write it directly because it is a very simplest program. Okay. And then what else? Initial approximation, let it be x naught or x int, whatever you want to write, and then the number of iterations. You give the number of iterations by your own self. Okay, so these are the inputs and outputs. So function is declared. The next step is the input things. So input things are function. You write the command inline for that, and inline calculates the particular value within that function. So start writing it in the brackets. So we start with brackets and then single inverted comma, and we use the our example which we have done in the basic class, that is x cube. So x cube means x to the power 3 minus x minus 1. Okay, and if you enclose this with the inverted comma, then it becomes purple. Now it is valid. If it is a red, then it means something is missing, so you enclose the bracket. Now in the next step you have to give a derivative by your own self of this function, and that is inline. What will be the derivative of x cube minus x? That will be 3x square minus 1. So write it 3 multiplied by x to the power 2 minus 1. So I think inverted comma is missing. Okay, single inverted comma, and then enclose it. Now it is valid. Okay, so this is done. And then initial approximation. So initial approximation for that particular example was, I remember, is 2 was the initial approximation. Okay, and what else? Number of iterations. Number of iterations you have to give by your own self. You know that the Newton's method can be solved within 5 to 10 iterations, 4 to 5 iterations, and then below 10. So maximum limit is 10. Okay, so this is done. Okay, now the next step is you have to utilize the initial approximation for the Newton's formula, because first iteration will be x1 equals to x naught minus f of x naught divided by f dash x naught df basically. So x naught basically is a constant, and you have to write the indices. And I have told you before that any index in Matlab, or any starting value of in that, or either it is a loop, either it is a condition, Matlab cannot read the value 0. So it will always start its index by 1. So you cannot use this x naught. X naught is a constant. So first iteration you have to give by your own self, and that is for x of 1 you have to utilize x naught, and then you can proceed any the iterative formula by any value. Okay, by any loop. Okay, so first is you have to select for I equals to 1. This is for the first iteration, x of 1. Now it is index. X of 1 means x1, so you have to give it to Matlab, and you have to utilize this constant. So x naught, if I use this x naught in the iterative formula, then it will assume again and again 2 values, so it will not proceed further and your values are not modified. So this is the basic reason, important reason to mention this. So f of x naught, because it is a constant, no need of index here, x naught is a constant, divided by df of x naught. If you want to write the brackets around df and f, you can write it, but Matlab assumes the rule of PDMAS rule, the first division and then subtraction and multiplication and all that, and then multiplication and addition, subtraction. So it will calculate x1, okay, and then you can use the loop, for loop or any loop. I use the value while I brackets I is less than equal to n. Within, it means while I is less than 10, do the iterative formula, Newton's formula again and again, and that is if x, now iterative formula becomes, here is, that is a fixed formula x of 1, and now I in the form of I it becomes iterative formula, because in the values of x are updated now. Xi plus 1 equals to x of I. So I is the index, and very important, I starts from 1 here, and it utilizes that 7th line, number 7, minus f of x of I divided by df of x of I. Okay, make sure that I haven't done any mistake here. Okay, so this is the iterative formula, and now the values of I are updated. So to update that value, I is equal to I plus 1. Okay, sensitive, so it is, we make sure that you haven't done any mistake. And one thing I forgot is to after the declaration of x is basically a variable. So to declare the variable you have to use the character x, because it is a string value, so you have to use after the function declaration you have to write character x, otherwise it will not display the output. So x is basically a variable which updates its value depending upon the iteration. So character space x, char space x is very important step, line number 2. Okay, so we have done, I'm sure, I hope that I haven't done any mistakes. So if it has a mistake, it will show. So one is for end, is for while, and the other end is for function. Now we run this program and you can see all the values. Yes, its root is 1.3247. First iteration has 1.5455, and then the further values, and after 4 and 5th iteration you can see that root starts to get repeated, so you can use the less number of iterations. So this is all about the Newton's method. Now we use the updated a very precise kind of method, that is how to find the root and how to find initial approximation by itself. So let it be comma b. So with the help of this interval you will be able to find out the root. So let a be, a is equal to 1 and b is equal to 2. So if then condition of opposite signs, if f of a multiply by opposite sign condition, apply this, f of a multiplied by f of b is greater than 0, that means same signs, then display error or print f, whatever you want to write. Root does not have same signs. Root does not lie in this interval. Okay, if not, if this condition is not met, then else do this. Okay, second derivative. Okay, next is for initial approximation, and else means you have to continue that initially. For the initial approximation you have to mention its second derivative. So after that I will write a dff, it's as second derivative, and dff you have to mention now its second derivative. So dff is equal to inline 3x square means 6x, its derivative 6 multiplied by x. So now you can use the condition. Else you have to check if if f of a, you have to check the endpoints, that whether one A is the endpoint or is the initial approximation, or the other one is the initial approximation. So f of A multiplied by dff of A have same signs, that is greater than 0, then A is the root, x naught equals to A, else x naught equals to b. Okay, so then you can start with the x naught. Okay, so and this is all the prerequisite condition for this. So and. Okay, yes, it is correct. Its answer is this. I hope that you understand this lecture.